So guys, now we are diving something a fundamental for a Android developers and security professionals, the Android architecture in security models. We would like to break down into an Android OS into its core layers, uh, including like a Linux kernel, HAL, Android runtime, and show how Android keeps a device secure. Now, we would like to get started. Now, once we would like to come and see here, overview of a Android architecture. Android is built on layered architecture. That flexibility performs a security. Like here, we would like to quickly we can look here. Number one, we would like to look here as in the Linux kernel. So this Linux kernel, the base layer managing a hardware and core services. And uh, HAL, like a hardware abstraction layer. It's a bridge between hardware and a software. In Android, it's mandatory is required. Every operating system that HAL must and should be present, including in either if you take like Linux, Windows, Mac OS, or any other things. Hardware abstraction layer, HAL is mandatory, where it will bridge together, where with the software and hardware. It will work like a bridge. That's it here. Now, uh, we would like to understand this about as a Android runtime. So, where your apps actually can run and execute. You can consider like you want to play like any type of music or something else in your Android phone that will utilize the HAL, hardware abstraction layer. If that bridge work connecting with hardware and software, then uh, this Android runtime will work exactly without any of errors, otherwise any type of misuse through this Android. Then we also look like native libraries of Java frameworks where powering a app functionalities for that and applications what a users interacts with each layer as its own role and system contributing to the overall functionalities and securities also. When you like to look here, uh, Android architecture, you can look here in this Android architecture. That I'd like to close this. So, in this case, when you have like applications like home, contacts, phone, browser, and first is a Linux kernel where you require a mandatory hardware abstraction layer. This is mandatory for interacting with your hard. It will work like a bridge where for your software and hardware to communicate each other. And Android framework like Activity Manager, Content Provider, Windows Manager, and System. Everything you can look in this case. Then native libraries like a Surface, Flinger, Media Framework, SQLite, WebKit. This and all work with the native libraries and Java framework and core libraries with the Android runtime. So where your apps actually can run and give the output, what else you are looking. That's it. Now, we come to a Linux kernel. So the Linux kernel is a foundation of Android. It handles the process and memory management and device drivers like camera, displays, sensors, power, battery, and handling. When also a networking, like you want to try to connect in your Android system as the Wi-Fi, where you can also try to get connected and do the network activities also, and security enforcements. And it may also support SC Linux, which enforces the security policies and prevents an unauthorized access between apps and system process also. So whenever you take a photo or a content to a Wi-Fi to the Linux kernel, is at work a behind the scenes, like a it will shows in this case, like let's you can look here in the Linux cases, like when you take to a in the photo, like if you launch a camera app, that will be stored with the process ID in the process management, and that will, once you capture the photo, that will store in the memory management and the file system. That's it here. This is how in the Android Linux system will be work. Every Android system have a Linux. So even you can also do a customization for your Android, like you can do the root for your Android. However, you can install a third-party apps also. In iPhone, you cannot able to install a third-party apps. Uh, in iPhone have a security, but the securities also can break in iPhone also. It now let's we would like to look here. Now we would like to look here. You can look here. I have told this. Now, hardware abstraction layer. Uh, we can call it as HAL. So, the HAL or a hardware abstraction layer acts like a translator. Like it allows a system services to use the hardware components like a camera, microphone, or a fingerprint sensors without having to know the hardware details. Each hardware functions has its own HAL module like camera HAL, audio HAL, graphic HAL, sensors HAL, GPS HAL, many other things. They have multiple HALs. Like if you try to get like let's consider you want to try to get a Android phone. In Android phone, you try to get like a default apps installed, like a camera, phone, everything. There is an HAL bridge. Okay, where this HAL is the main bridge, where uh, this will act as a bridge to communicate with the software and hardware. Like you in your phone, Android phone, you want to start a camera and capture the moon surface. So where that camera HAL will activate and the camera will launch, you can capture, and that once you have once you open the camera, that the process management will get the processor ID. And once you have done any operation, that will store the memory management, then that will be stored the instant of your image into in your gallery or file storage system. That's it. This is how HAL will be work here. Now, now let's we would like to go for Android runtime. So then we have like a Android runtime. This is where your apps actually run. Android runtime replace like a Dalvik version, a Dalvik machine of Android. Uh, is a 5.0 introduced in like ahead of times, like compilations, turning your apps into a bytecode into a native machine's code at a install time, app setup speed, battery performance, and like a runtime security. And Android runtime also manages the memory, threading, garbage collections, and core libraries like a Java standard libraries. So every time you open an app, ART is a behind on it, and it will also uh, store your cache memory. Like once you have opened bulk apps, and if you type your backend apps, like if you want to scroll up, otherwise, if you want to cut to in your cache memory, that also will be stored over there. So you just need to delete all. So, like see here, garbage collections, thread management, memory allocation, and debugging and profiling tools also can be done here. Now, once you'd like to look here, Android security models. Android architecture also enables a strong security model like a key features include like a sandboxing, permissions, app signing, SC Linux, verify for the boot also. Like, let me, I can show you here. Uh, can't able to write. Like, when you would like to go for as a, no, I cannot able to write here. For a sandbox. That is also in sandbox. When you go for a Android security, each app run its own isolated environment. Let's consider you have an ISO image like Kali Linux, otherwise Android ISO. You want to run in like a virtual machine. So in every Android OS, if you upload your app into a Play Store, that will go to an Android a sandbox environment that will run in front of you, direct, where it will work like a virtual environment. And when you go for a permissions, once you have installed, when you try to go to a Play Store or some other things, you try to get a app must be explicitly a request a access a data like a camera locations and everything. I would like to tell you, please carefully try to look. Don't try to install the Facebook or messengers or WhatsApp or many other things. Where these people, they're going to sell your data to a third party organizations. Like, let's consider you open a Facebook, otherwise you install a Facebook. You just need to provide your locations and each and everything or what else your interest. When you try to search again, the same thing like either in Chrome, either in Firefox, either in Safari, you can get exactly what you have searched that related ads only. So where they are making, utilizing your personal data to make the money. So always try to give the uh, responsible permissions what you required only. Don't try to give what else they requested to you. And once you have download the app, it will ensures the app integrity and authenticity. So you need to sign for the app once you have download. Like you have download with a particular uh, a Gmail ID in a Google Play Store that you would like to sign in. Also protect for Google Play protection also. That will be available on every when you download by uh, Google Play Store. When you download from another Play Store that you not get any type of protections that will be automatically can inject to a malwares in your Android system, otherwise in Android app, Android mobile. So everything will run in SE Linux enforces a strict policies and Linux kernels also. And once you have uh, download the app, it will verify the boot and prevents a tamper system image for loading. Once you have installed, then it will try to load. It will take for installation like less than a 1 minute. That's it. So this is how Android OS architecture, Linux, kernel, HAL, Android runtime will work. Next, we would like to discuss about Android security models like app sandboxing and permissions also. That's